This is a video for MEI Core Pure Mathematics, Hyperbolic Functions 2, Inverse Hyperbolic Functions, 2.1, Inverse Hyperbolic Functions. The inverse of a function can be found by using a reflection in the line y equals x. We have a look at this graph. I've got a red line here, red curve, which is y equals sin x, and the black line is y equals x. If I reflect y equals sin x in y equals x, I get this blue curve, and this is arcsin x, the inverse sin of x. So there are two ways of writing arcsin x. We can write it as arcsin or sin to the minus 1 of x. Either way, it's the inverse of sin x. Now, x equals fy is a reflection of y equals fx in that line y equals x, and this gives us a hint as to an algebraic method to find an expression for arcsin x. Let's have a look a bit more closely at that and see how it works. We've got here y is equal to arcsin x, and that means I can write sin y equals x. So working from the definition for sin y, I get that x is equal to this thing, and the plan now is to get e to the y in terms of x. To do that, I'm going to multiply through by 2e to the y, so I'll get 2x e to the y is equal to e to the 2y minus 1. And rearranging, I'll get e to the 2y minus 2x e to the y minus 1 equals 0. And this is effectively a quadratic in e to the y. I've got an e to the y squared here, an e to the y term, and a constant. And to solve this, I'm going to complete the square. So if we look at e to the y minus x squared, e to the y minus x all squared is going to give me these two bits plus an additional x squared, so I need to take off an x squared minus 1 equals 0. And then rearranging and square rooting, I'm going to get that e to the y minus x is equal to plus or minus the square root of x squared plus 1, and therefore e to the y is equal to x plus or minus the square root of x squared plus 1. Now if we look at this, the root of x squared plus 1 is going to be bigger than x, so if I have the negative square root, this whole right hand side here will be negative, and therefore there is no real y for which e to the y is equal to a negative number. So I'm just going to take the positive square root, and therefore taking logs of both sides, I'm going to get that y is the log of x plus root x squared plus 1. There's that written up a little bit more tidily. There's the original setup that we had, and then we get down to the quadratic in e to the y with the solutions to that from completing the square, and then the indication that arcsin x is equal to the log of x plus root x squared plus 1 only, and we know that e to the y isn't defined for the other root. Now, what about the inverse of cosh x? Well, if we have a look at the graph over here, we can see that I've only got part of the curve that I've reflected. And in fact, what I'm going to do is I'm going to remove this part from the definition by saying that I'm only going to consider y equals cosh x for x greater than or equal to 0. And this is a very common trick with even functions. If you think about something like y equals x squared, when we do the inverse of x squared, we actually just take the positive square root. And so here we're just taking the positive, if you like, the positive version of arccosh x. In fact, when you do an inverse cosh, you will get two values, although the function will only give you one of them. There are two solutions if I had something like cosh x equals 2, I would get a solution here, and I would get a solution here. And again, because cosh is an even function, whatever I get here, I would get minus it over here. The cosh of minus x is equal to the cosh of x. Now, if we work through the algebra for that, I get down to a similar looking quadratic in e to the y, and therefore I get down to this result. Now, both of these are valid, so I can have either of those, but I've restricted here my arccosh x to greater than 0, so for the function I'm only going to take the positive square root. So as I said, you'll get two solutions to an equation, but arccosh x is only log of x plus the square root of x squared minus 1. Now, in a similar way, we can show that arctanh x is a half log 1 plus x over 1 minus x, as I've got here. And there's a couple of things to notice from the graph. Tanh x is asymptotic to minus 1 down here and plus 1 up here. And therefore, the domain for our tanh x is restricted. Tanh x can't take a value higher than 1, and therefore our tanh x cannot have a value for x that's higher than 1. And in fact, x is less than 1 and greater than minus 1 for our tanh x. If you think about the limits, if x was allowed to be minus 1, then this would be 0. We'd be finding the log of 0, which we can't do. And if x was 1, this thing would be undefined because I'd have a 0 on the bottom. And again, we couldn't find that log. So those are our limits on x, our restrictions on x. Let's have a look at a quick example using inverse functions. 2 cosh x minus 6 equals 0. So from that, I'll get cosh x equals 3. And so x is arccosh of 3. And so using the logarithmic form here, x is just the log of 3 plus the square root of 3 squared minus 1. And so x is equal to the log of 3 plus root 8. But as we saw on our slide about arccosh x, there is another solution. So this comes through from the function, but there is another solution which is the minus of that, and actually that is also the log of 3 minus root 8. And there's a nice quick piece of work here to show that the log of 3 minus root 8 is equal to minus the log of 3 plus root 8. And remember, that's coming from here for our function, giving us the two possible values. That from the function. And this one from knowing that there are two possible values and how they're formed. Okay, so there's that written up again a little bit more clearly so you can see it. This tracks through in exactly the same way as I had before, and here are my two possible solutions, the log of 3 plus root 8 and the log of 3 minus root 8. So finally, in summary then, these are our logarithmic forms. Our sin x is log of x plus root x squared plus 1. Our cosh x is the log of x plus root x squared minus 1. And there is a restriction on that, which is that actually x has to be greater than or equal to 1. And our tanh x is this thing, a half log 1 plus x over 1 minus x. And again, there are restrictions on that, that x is between minus 1 and 1 and is not equal to either of those limits. Now, these formulae are in your formula book, but it is important to remember them, at least remember that they're there, and to understand the restrictions that are placed on arccosh and arctanh. The next video in this sequence is 2.2, differentiating inverse hyperbolic functions.